Today we're going to review some of the conjectures that we've looked at in Chapter 4. Actually, I think it's all of them. And then we're going to see how those are used to prove things. So the first one is the triangle sum conjecture. I'm going to summarize these, so if you want the full conjecture, you can of course look in your book or at previous podcasts. So the first one, triangle sum conjecture, we know in a triangle, the sum of the measures of all the angles is 180 degrees. The sum of the angles is 180 degrees. Okay. There's a third angle conjecture that says if two angles in one triangle are congruent to two angles in another triangle, the third angles are congruent. Okay. Next one is the isosceles triangle conjecture, which just says if a triangle is isosceles, the base angles are congruent. If a triangle is isosceles, the base angles are congruent. The converse is switch the order, so if the base angles are congruent, then the triangle is isosceles. Triangle inequality conjecture just says the sum of the two smaller sides must be greater than the sum of the third side, the largest side, we'll say. Oh, not the sum, just must be greater than the largest side. Okay, and that will form a triangle. The side angle inequality conjecture just says in a triangle, if one side is longer than the other, well, basically it says that the largest side is across from the largest angle. And likewise, the middle side is across from the middle angle, and the smallest side is across from the smallest angle. The triangle exterior angle conjecture, I'm going to just draw this one out. Let's say we have a triangle. All right, we have the two remote interior angles. Angle 1 plus angle 2 is going to equal angle 3. Side, side, side conjecture just says if you have two triangles, where you know the sides are congruent, then the triangles are congruent. Side angle side just means if you have two triangles with a side, an angle, and a side, that's congruent to another triangle, side angle side. These are congruent triangles. Angle side angle just says if we have an angle, a side, and an angle, congruent to an angle, a side, and an angle, these are congruent triangles. And that just means it's the minimum amount of information you need to show that the triangles are exactly the same without measuring all 6 angles and all 6 sides. Side angle congruence conjecture. Again, if you have a side, an angle, and an angle, congruent to a side, an angle, and an angle, these triangles are congruent. The vertex angle bisector conjecture just says in an isosceles triangle, the bisector of the vertex angle is also the altitude and median to the base. Equilateral equiangular conjecture. Every equilateral triangle is equiangular, and vice versa. Every equiangular triangle is equilateral. CPCTC, corresponding sides, corresponding parts, sorry. Of congruent triangles are congruent. And the rest of our review, you need to know vertical angles are congruent. So angles 1 and 2 are congruent. Likewise, these two angles are congruent. Linear pair, angles 1 and 2 add to a straight line. Angles 1 and angle 2 add to a straight line. Same segment. You might have a picture like this, where they share a segment in both triangles. Definition of a midpoint. A midpoint divides two sides into two equal parts. An angle bisector cuts an angle into two equal parts. If you have parallel lines, the alternate interior angles are congruent. If you have parallel lines, the alternate exterior angles are congruent. So here's your parallel lines. Here's the interior angles. The exterior angles are congruent. So this angle is equal to this angle. This angle is equal to this angle. Corresponding angles, angles in the same location, are congruent. So like this angle and this angle would be congruent, and so on. And consecutive interior angles are supplementary. So if they're right next to each other, they add to 180. All right, so we just review all the different properties, and then we're going to go ahead and take a look at how they're used. So there's this worksheet called Making Conclusions. All right, so first step, state the given, give the reason, and mark the figures appropriately. So we'll do a couple together, but your assignment will be to complete this. So the first one, M is the midpoint of AC, so you have to mark what's true. So the midpoint of AC, these two are congruent. M is the midpoint of BD, so these are congruent. All right, so we want to use one of those theorems. So side, 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 angle, side, angle, or side, angle, angle. All right, so this one right here, we know vertical angles are congruent. So we would say the conclusion is triangle BMA is congruent to triangle DMC. So name them in the corresponding order. The reason would be side, angle, side. All right, the next one. AB is parallel to DE, so AB is parallel. Okay, that's marked. Conclusions, well, we have alternate interior angles that are equal. So the measure of angle A is congruent to the measure of angle E. Also, these angles are congruent. Measure of angle B is congruent to the measure of angle D. And the reason, alternate interior angles are congruent. All right, we'll do a couple more. Okay, given is the diagram. All right, well, we have a remote interior angles and the exterior angles. So angle 1 equals angle 2 plus angle 3. Reason, exterior angle conjecture. And one more, and you could do the back. BD bisects angle ABC, so these two angles are the same. And conclusion, angle ABD is congruent to angle CBD. Reason that's the definition of an angle bisector. So the back of the worksheet, you're just going to practice making conclusions based on the picture, and we'll correct.